All right, so today's goal is going to build a little mini game using SpriteKit. Now here's what the end product's going to look like. So I'm going to run it. It's going to be on an iPhone 7, and as it loads, there we go. So we're going to have our hero here in the corner. We have all these bad guys. So they'll be flying along. Of course, no magic or animations or explosions. We won't have time for that today. But all we're gonna do is just have our guy float around the screen, and have it rotate and do a little spinning action, and just have the bad guy just flying across the screen, and that's the end product for today. All right. So first thing we're gonna do is create a file, new project. Right. So file, new, and then project. And then we'll come to our usual screen here. Instead of choosing single view application like we always do, we're going to actually choose game. So we're going to go with the pre-built game that Apple has produced within the Xcode. So iOS game this time. Hit next. Language is Swift. And I call this my game. And we're going to use SpriteKit as the game technology. But you can see for game technology, you have the option of SpriteKit, SceneKit, and Metal. So those are your options for when you want to produce games. You can integrate Gameplay Kit. So Gameplay Kit is a kit that Apple produced and released last year. It's useful for when you want to record your game or allow your user to record their game to publish online. So you may have seen on YouTube, you can watch people playing their games, right? And so Apple has incorporated that feature directly into iOS. So you can integrate Gameplay Kit directly, and if you want, we're going to avoid that for today because we won't have the time for it. Go straight to next and give it a home. All right. And first thing I'm going to do is I'm going to organize all of my code into folders because we're going to have quite a few folders here. So let's say new group, images. So we're bringing images this time around. And view controllers. And classes. Storyboards. And finally, scenes for our game stuff. So I'll move all my files over. I'm going to put gamescene.sks, actions.sk, which we'll come back and discuss in a moment, into scenes. Game view controller into view controllers. Main storyboard and launch screen.storyboard into storyboards. And I'm going to start by bringing in my images. So I'll expand everything just so you can see what's there. Images is empty. So I'm going to add files to my game and locate where my images are. And I'll select my images. So city.jpg will be my background. Donkey.png will be my bad guy. And monkey.png will be my good guy. And don't forget options, copy items if needed, should be checked. And we'll hit add. And so here are my images that I'm going to play with. And of course, we're going to use asset catalogs, but for time, we're not going to worry about that. Now, Donkey, you'll notice, is facing this way, but in our game, we're going to have him facing the other way. So we're going to learn how to take an image and inverse it, or rotate it amongst the horizontal axis, and so that it'll actually point the way we want it to point. Now, first thing I'm going to do is I'm actually going to run this as is. So I'm going to throw this onto an iPhone 7, and I'm just going to hit play. Because it actually has pre-built stuff that we can work with. Right? So it comes up with hello world, as is. And you can click and that little animation is going to happen. I'm actually going to keep that. If I swipe, it does that. And so it actually has sample code to show you how to do all that, which is really convenient on Apple's part. Also, another animation, the hello world goes back and comes back. So it goes ways and come back. So you can play around with that just to see, and you can see the code that goes on behind it. Now what we're going to start off in GameScene.SKS and look at what's there. And it looks a lot like Interface Builder. So I'm going to zoom out. You see it looks a lot like a view controller view from a storyboard. Right? I'm actually going to bring back the document template because all of our assets will be listed right here. So what we're going to do is we're going to start by just configuring this to adapt to what we want it to be. On the other hand, other things that are there, action.sks, this is useful for animations. And so you can have like proper timing and whatnot for your animations. It's very similar to what Adobe Photoshop uses for their animated GIFs. You actually have timing there as well. And then there's GameScene.Swift, which is where we're going to focus all of our code on. So we discussed this method didMove. This is kind of like the view-did-load type method that you see in view controllers. So it's where our init code goes in. And we're going to focus all our energy on putting our code in here today. Right? I'm also going to point you to GameViewController.Swift. And here we have our view-did-load. Its purpose is to just load that first game scene, which is basically the game scene we have defined up here in our scenes. And that's it. That's all it is. So we're not going to touch view controller at all today. App delegate, we're not going to touch either. And so let's start off our work in GameScene.SKS. So what I want to do is I want to have a white background. So just by having the scene highlighted and having my entire world here, looking off to my my inspector on the side here, this is the attributes inspector, I'm going to change my color from black to white. But then my hello label goes away. So I have to make that visible again. All right? And so what I'm going to do is I'm going to change the text there, the color, to be red. And you have the ability to change the font. I'll keep the font the same, but I'll probably adjust just the font size. But you can play around with the font as you see fit. And with Hello World, I'm going to leave that there for a sec because I want to build a landscape app today. So to do that, I can rotate the positioning of my screen by just clicking on Scene again and noticing the sizing here. It's saying that is 750 wide by 1334 high. I'm going to swap those numbers. So this will be 1334. The other one will be 750. And when I do that, it has become landscape. So now it's a landscape scene. And then that allows me to edit my text hello world to be my title of my game. Actually put it under the word text. There. And you'll notice that the text goes beyond the bounds, so I'm going to reduce the font there. There. So it fits nicely on the screen. Now on top of the label, there's a circle here. So I can use this circle to rotate and move this item. All right? And if I click on the blue circle, I can rotate it among the axes. I won't do it because I want to keep it nice and balanced. So I'm going to leave it like that. I'm going to leave my title as hello label as well. Now, what I also want to do is I want to bring over a couple more labels, put them at the bottom. One will be for my score, and the other one will be for like sort of instructions for what the user is going to have to do. So I'm going to look for a label. And you'll notice that down here is very similar to our interface builder, our tool palette essentially, except it has different tools here, and all of them related to gaming. So for example, emitters, lighting, color sprites, all these different things. So I'm going to bring over a label, just place it, and it starts off really small, and the color is white, so it's not even visible. I'm going to use blue for my font, and just set the text to be, score, :0 and increase that font till it's visible. So this will keep track of our score. And then one more label. Place it right there. And this will be some instructions like help monkey hit as many donkeys as he can. And increase that font size as well. Maybe do a bit of adjustment there. And we should give some ID to all of our items. So what we want to do is, you notice that the title here is SK label node. It's pretty generic. So I'm going to call this first one for the score under name. And for the instructions we have for the second label, I'll call it rules. And so essentially now I have my home screen there, and everything's out and labeled. All right, so the next step now is we're going to get our good guy to appear, and as well, we're going to get our background image to appear. So I'm going to start off with the background image. So all of our work now is going to happen in GameScene.Swift. And inside GameScene.Swift, we have didMove. We have some predefined items. Those are related to our hello world. And now, what we're going to do is we're going to start off by defining a couple of variables here. So over here, I'm going to say var background is equal to sk sprite node, and it'll be image named, and I'm going to call it city.jpg, just what we have on the side there. And the other thing I'm going to define is my good guy. So I'm going to say private var sport node extends sk sprite node question mark. All right. So now the first step I'm going to do is I'm going to try and get the background to appear. To do that, inside didMove, right at the beginning of didMove, beyond what's over here already, I want to get the background to appear first, so it doesn't overlay on top of anything else. So to get the background to appear, we've already defined it as a sprite node. We're going to specify its position. So we'll say background.position is equal to CG point and say X, and we'll provide the location of it. So I'm going to say frame.size.width over 2, and then frame.size.height over 2. Now I want to fade it out, but before doing that, I'm just going to add this as a child so we can view it. So we'll say add child background and give it a run. See what it looks like. All right, and let's look at what happened here. So our image is actually off to the side here. But what I tried to do is say, fill the screen. So the bottom left quadrant of that image is populating over here. That tells you that my origin down here is 0, 0. My origin is actually in the center of the screen right now. And so I need to move that origin. I want it to be down here in the corner, the bottom left. That's a quick fix. So to fix that, I'm going to go back to gamescene.sks. And this plus sign that's right in the middle, I'm going to adjust it. But I'll do it in code, or in the attributes inspector. So there's a setting here under scene, making sure scene's highlighted, called anchor point. And so anchor point set to 0.5.5, which is basically like 50% of the way through, both width and height. I'm going to change that to 0, 0. So 0, 0. When I do that, everything moves. Everything moves. So my origin is now the bottom left corner, but I can bring everything back. So I'm going to start highlighting or pre-selecting all 3 items and then just dragging it back to where I want it. There. So now everything's back to where it is, and if I run it again, I should see the full image. So now my full image is covering the screen there. All right. Now it's a pretty dark scene, and so it'll be tough to read a lot of the labels and a lot of the characters that are on there. So I'm going to fade it out a bit. So to do that, there's the alpha setting. So I'm going to say background.alpha equals, I'm going to fade it to be really faint. So like 0.2. I'm going to try running it again. Just see what it looks like. There we go. So now we can see everything nicely. Now we have a background texture. We can still see everything nicely. It just looks like a nice, elegant texture. All right. So that was our background image. Right? Just being able to get the background image to appear. We're going to take the very similar approach, very same approach, but just use it to add our good guy. Now I'm going to actually do this below, or actually at the bottom of my didMove method, down here at the bottom. So I'm going to skip over all that extra code. I'm going to leave that in there because I think it's nice, so we'll let it be. And to do that, I'm going to say sport node equals SKSprite node image named. I'm going to use monkey.png. There, I'd rather just see the full name of the text instead. All right. I'm going to set its position to be like 1010, which is the bottom left corner, just 10 pixels over, so you see pieces of it. So we'll say sport node dot position is equal to CG point, where we're going to say 10, 10. Just hard code to the bottom corner of the screen. And then add child for sport node, exclamation mark. All right, and then run that again. You should see our hero in the bottom corner of the screen. There we go. Monkey's just right there in the corner. If I click around, nothing happens other than the original animation sprites that Apple provided. Other than that, monkey won't move yet. We're going to make him move later on. All right, so the next step now is let's add the bad guy. Let's add our bad guy in. So moving down, I'm going to actually add it just after did move. But first thing I'm going to do is add some functions to do some random number generation so that it'll randomly place the bad guy in different places. So I'm going to add two functions. The first function, we'll say func random, returns a CG float. And we're going to use a method called arc4random that's built into iOS, both in Objective-C and in Swift. So we're going to return CG float. We're going to cast it to float for arc4random divided by 0x ff. So it's going to scale it between that value and the maximum int size. So we're really getting a random number here. We're going to create one more random function right below. This one we're actually going to call. So func random. But we're going to pass in a min and a max value. So min will be CG float, and max will be CG float. Still returning a CG float. And that will return a call to random times max minus min plus min. Max minus min plus min. So we're actually going to call this second one, and we're going to use this to range our random value between a location that fits our screen, and just add a little bit more to it using the random function above. So again, gaming is all about randomness. So we're creating random functions to do some randomization, so it can look like we have a more realistic attack of bad guys along the screen. So now that we have our random functions out of the way, let's add some bad guys. So I'm going to create a method right below, func add baddie. And so we're going to define our bad guy. So we're going to say let baddie equal SKSpriteNode, and it'll be image named. This one will be donkey.png. Now, because the image itself is facing right, I want it to face left, so it looks like it's coming at monkey. So I'm going to flip it along the horizontal axis. To do that, I'm going to say baddie.xscale equals baddie.xscale times -1. So that'll rotate it along the horizontal axis. Or sorry, the vertical axis. Yeah. And so that way it looks like it's facing towards the left. Now, in terms of positioning, I'm going to start off at the extreme end of the screen, so down here, and it's going to float its way across the screen. That's the idea. So the X position will start off at the end, and we'll use animations or sequencing actions to move it and to change the X. But the Y will randomly pick between the bottom of the screen and the top of the screen. So we'll use the random number over here that we define, and so that'll be our Y. And the Y will stay the same the entire time. And so the nice thing is that you can probably play with the Y to have it go floating up and down diagonally, really add some charisma to the character animation later on. So what we're going to do is we're going to create a variable called actual Y. So let actual Y equal random. We're going to pass in our minimum value being baddie.size.height over 2. Our max being our size.height, which is our screen size, minus baddie.size.height over 2. So we're going to have a random value that'll be displayed between actually the screen down here and the screen up there. So anywhere between the bottom and top of the screen for our phone along the y-axis. Now we're going to set the position for baddie. So we'll say baddie.position is equal to CG point, and we'll say x for size.width, y will be actual y. And actually for x, we'll say size.width, but we're going to factor in the bad guy size. So adding in baddie.size.width over 2. Okay. At this point, we'll use add 'em. So we'll say add child for baddie. Now we want to make them animate. So right now, well, if we were to run this, right now it won't do anything because we're not even calling add baddie. But when we do, we want them to move along the screen. So we're going to specify that it'll take between 2 and 4 seconds to move across the screen. So we'll have different bad guys floating across the screen at different rates. So look very random. So I'm going to create a new variable down here. I add some extra space because we'll come back to it. So I'm going to say let actual duration equal random for a min passing in CG float casted of 2.0 because they're doubles by default, and CG float for 4.0. There. So we're gonna let actual duration generate a random number between 2 and 4 seconds. Oh, one too many randoms in there. There. All right. Now we're going to create an action. So the action from the object SK action, that's actually going to help us with our animation or our movements for our sprites. So we're going to say let action move equal SK action dot move to did not complete. Move to. We want to move it to the other end. So it's the 0 point, which is on this side of the screen. So the left-hand side of the screen. So we want to say, all right, so when it moves, after it's done, we're going to create another action that will make it disappear because we don't want to keep the bad guys on the screen still. So we're going to create a second action we call let action move done equal sk action dot remove from parent. And then we're creating an action sequence. So the sequence will actually execute move and then move done right after. So we're going to use sk action sequence to do this. So we're going to say baddie.run for sk action dot sequence, providing an array of items, which in this case will be action move, comma action move done. And so that'll be our entire bad guy. The only thing missing, I left a gap here on purpose, was because we're going to add some physics later on to detect collisions. So I left that space there on purpose. So we're going to come back to it. But this still isn't enough to run. You could run it right now, you still won't see bad guys. So to do that, we have to create a repeating function that'll constantly repeat add baddie and constantly generate bad guys to appear on the screen and to move. All right, so now the next step is to call add baddie. I'm going to call it inside did move. and I call it repeatedly. So moving up to did move, just below this add child for sport node, some space there because we're going to come back to it. And I'm going to say run skaction.repeat forever. So during forever, as long as the game is running. So skaction.sequence. So I'm going to create a sequence of actions here. And the first one will just be skaction.run for add baddie. The second item in the array will be skaction.wait. And how long I'm going to wait for? I'm going to wait for half a second before running it again. So I want to put a delay between executing add baddie. So we'll say 0.5. And there, that looks like all of my brackets match up. Now we can run this. Because we made a little mistake here. We're going to fix it right now. Random, actually that bracket's out of place. So it's resetting it to the same number the entire time because it's so small. So that we got to move the bracket over. So now if I run it, right? So now Donkey's appearing in different places. And some are moving faster than others. All right, so now at this point, let's get our hero to move. So we're going to look at some of the movement functions below. There's a method called touchdown. So we look at actually a bunch of the methods we have here. We have touchdown, touch move, touch up, touches began, touches moved, touches ended, touches canceled. I'm going to go down to over to touchdown. And I'm going to create an additional movement. I'll actually leave what's in there. And you know, it has that nice animation effect. So we'll leave it there. I think it's nice to keep. But what I'm going to do is create a new method just above touchdown and call it func move good guy. And the argument passed in will be 2.POS of type CG_point. And here, I'm going to do another action sequence. So I want it to move and then spin after it's done moving. So I'm going to say let action move equal skaction.move to I want it to move to POS. So PS will be passed in. And duration will be time interval of 2.0. A bit of a typo there. So 2 points should not have a colon next to it, just to fix that. And then we're going to do our action move done, which will be like a rotation. So I'll say let action move done equal skaction dot rotate. Rotate by angle. And let's make it do a 360. So CG float of 360.0, duration, time interval of 2 seconds again. And then we can say sport node dot run for skaction.sequence, and then have our list. So action move, action move done. So we have our method good guy. And in fact, I put in a separate method because I want to actually run it in both touchdown and touch moved. So touchdown just to press down, or if I want to just swipe it to that other location, we can still run this method as well. So I'm going to put it at the end of touchdown. So move good guy to point POS, because that's the position that's passed in. And move good guy to POS. So touchdown, touch move gets a CG point, XY location of where it's been touched. And so now we're going to call move good guy and pass that same XY location to there. If I run it again, and let's move them. So there you go. I'll do a little rotation. Maybe I'll swipe this way, and he actually moves and rotates at a certain point as well. In fact, our movement, he kind of follows at the same time. And so now we've got movement in place. Okay, so at this point, we've got our game up and running. We know to move the character. We got bad guys flying in all over the place. And now what we want to do is we want to add some physics. So can we have some collision detection? Now, normally in a game, when things collide, they might bump away or maybe have some explosion or some guy dying or something. But we're not going to do that. We're just going to use it to increment our score counter. We're just going to let them collide right through each other just for time's sake. All right, so, but you could extend that if you wanted to do so. You could take it as far as you want to go. But to do that, we have to bring in an interface. All right, and so I'm gonna go to the top of my file under game scene, extending game scene. We're going to bring in extending SK scene, comma, SK physics contact delegate. So that has all the interface stuff we need for getting our physics, our collision detection, all those things for colliding two items together. Now to do that, we're actually going to define a structure just above it. And this one will just have some defines that will track we will use to track whether what was hit and what it hit at the same time. So we're going to say struct and call it physics category. And we'll say static let none extending u int 32 equals 0. And we'll say static let all extend u int 32 equal u int 32.max. So the largest int value possible for unsigned int. We'll say static let baddie extend u int 32. We're going to say OB1 or 0B1. So binary 1. So binary 1. Then we'll say static let hero extending u int 32 equal 0 binary 1 0, which is 2. So this is binary 1, this is binary 2. We're using binary here for our values for a reason. We'll see that later. Now suppose you wanted to go even further. Suppose you want to have more categories of characters, like maybe non-player characters, some random person walking, or you want to fire lasers. You can keep adding stuff. So, I might just add one more. We're not going to use it, but I'll say static let projectile extend uint32, let that equal to binary 1, 1, which is 3. Right? And you keep going. You can keep listing out characters, pieces, items, all through your game in this list here. We're only going to play with baddie and hero. All right. So now, once we've created our categories of characters, the next step is to start adding gravity and physics to our world. And so I'm going to start down in did move. Just after adding our little sport node for the first time, I'm going to enable some physics. So I'm going to say physics world, which is already defined. So I didn't define it anywhere. It was already defined in the contact delegate. So I'm going to start using it. So physics world at gravity is equal to CG vector dx. We're going to set them to 0 and 0. So gravity is below us essentially. And we're going to say the contact delegate is itself. So physics world dot contact delegate equals self. So this object will have gravity. Right. And now what we're going to do is we're going to move on to adding physics to our bad guy first. So we left a little gap in add baddie. I left it on purpose because I want to add physics later on, which is now. So inside here, just after adding the child, we're going to add physics to our bad guy. So we're going to say baddie.physicsBody is equal to skPhysicsBody rectangle of, and we'll say baddie.size. So there were a few options for physics bodies. The idea is that we're taking our item, our bad guy, and we're going to put almost like a force field around it, right? In this case, in the shape of a rectangle, because our bad guy's in the shape of a rectangle. And that force field won't really be what you'd think would protect you. It's just sort of to detect if something has touched that force field. All right, and so that's why we're saying rectangle of baddie. We're just basically putting like a sensor around our bad guy based on the edges of our image. All right, so that's what we're doing. There's actually a circle of as well, which we could use for our good guy if we wanted, just to show how it's done. Maybe we'll do it later. Next step, we're going to say baddie.physicsBody (.isDynamic) equals true. So we're going to say, it's dynamically changing all the time. Now the next one is, what are we going to categorize our bad guy as? We created these physics categories above a moment ago. We said bad guy, hero, projectile. So we're going to categorize this so that when we detect a collision, we know what was hit. So baddie.physicsBody (.category bitmask) is equal to physics category .baddie. All right. So every time a collision occurs, and we're going to write the collision code later on, we're going to check to see if it was physics.baddie, physics category.baddie that was hit. All right. That'll tell us. Now we can tell it what to test for all the time. We always want to check for maybe a particular bad guy. Maybe we only want to check for collisions between certain items. So we can do that here. We're going to say we're always going to check for the hero. So we'll say baddie.physicsBody (.contact test bitmask is equal to physics category .hero. So we're always testing for the hero. And we'll say baddie.physicsBody (.collision bitmask is equal to physics category .none. So we're just going to test for contact with any item, well, with our hero in this case, but not for any collisions. Now the next step is we added physics to our bad guy. We still have to add physics to our good guy. And we'll do that physics for the good guy back in did move. So moving up to did move, where we actually added our gravity, we're going to continue on with adding physics to our sport node. So we're going to say sport node dot physics body is equal to sk physics body, and just to be different, we're going to say circle of radius. Realistically, rectangle is probably a better choice because it's a square, but just to illustrate that we can use something else. So we'll say circle of radius, and we'll say sport node question mark dot size dot width over 2. So that's our we're gonna create a larger radius around our character, our hero. We're also going to say that it's dynamic. So we're going to basically write the same code we did for the bad guy, but now for the good guy. So we're going to say sport node dot physics body dot is dynamic equals true. Category bit mask. So we'll say sport node physics body dot category bit mask. This time it's going to be physics category dot hero. And we're going to test for body dot contact test bit mask is equal to physics category dot baddie. And finally, dot collision bit mask is equal to physics category dot none. Just to make it easier to read. Now that will be good enough, but I'm gonna add in another setting. It's not necessary, but it's useful for, suppose you have a very complex character, really odd shaped, and you want to be very precise in your collision. You have that option here. So I'll add that in anyway. So we'll say sport node dot physics body dot uses precise collision detection, set it equal to true, for some really complex characters. All right, and so that's collision detection. But the question now is, well, what happens if something collides? So what do we do then? In our case, we just want to have the score increase. So what we're going to do is add a couple more methods. I'm going to put that method at the end of add baddie. So before move good guy, I create a method, func hero did collide with baddie. We're going to pass in our two, both our hero and our baddie. So we'll say hero, so our two objects, sk sprite node, and baddie, sk sprite node. And right now, all I'm going to do is say print hit. We'll have our console tell us that hits were happening for now, just for now. We're going to add more later, so I'll leave some space there. Now, we're going to add one more method, and this method is already belongs inside the contact delegate, so we're actually just bringing it in. We'll say func did begin. There it is. So let it autocomplete. So did begin. And so now what we're going to do is in this method, we're going to test for our collision. We're going to test to see who collided with who. Now, realistically, we only have two items here, hero and bad guy. They're both going to collide with each other. But we're still going to write our test code for it anyway. So we're going to have two bodies here. We're going to say var first body extends sk physics body, and then var second body extends sk physics body. There. Now, the category bit masks that we set a moment ago, we're going to use that to test to see who hit who. So we're going to say if contact.body A. So notice the argument passed in is contact, which actually has both bodies that collided. So in this case, it'll be both hero and bad guy. It's just a matter of is body A hero and body B bad guy, or is body A bad guy and body B hero. So we're going to use that to test to see who hit who. But in our case, they both hit each other, so it doesn't really matter how that appears. But we're just going to test for it anyway. So we'll say contact.bodyA.category bitmask. If that's less than contact.bodyB.category bitmask, then first body is equal to contact.bodyA. Second body is equal to contact.bodyB. Otherwise, it's the reverse. So first body becomes contact.bodyB, and second body becomes contact.bodyA. So we're using the less than symbol because baddie was 1 and hero was 2. So we're testing to see if bad guy, if basically body A is bad guy and body B is hero, then we're going to set first body as A and second body as B. Otherwise, we're saying that hero is body A as the first body and bad guy is body B. But we need that to determine how we're going to call our method above. Hero did collide with baddie. So now we're going to say, and to end off this method, if first body dot category bitmask ended with physics category dot baddie does not equal 0, meaning that they're not this, meaning that they're not the same, and second body dot category bitmask ended with physics category dot hero does not equal 0. Then we'll call our hero did collide with baddie, passing in first body dot node as SKSprite node, and second body dot node as SKSprite node. All right, and that should be enough to run. Oh, I'm missing a bracket. Oh, actually not a bracket, it's a spacing issue. There. That should be enough to run. and we run it, we're just looking at our console. All right. So you can see the word hit appearing down on my console down here. Right? So it's appearing down there. Right? So I know that collisions are occurring. Right? Lots of hits. So now I have collision detection in place. All right. So now we have collision detection going. Our last step to do is to add some scoring. So what we're going to do is we're going to declare a couple of variables at the top. So below our declaration of sport node, we're going to add 3 more variables. So I'm going to say private var score extends int question mark. We're going to say let score increment equal 10. So every time there's a collision, we're going to say add 10 points. And we'll say private var LBL score extends SK label node question mark. So we're going to link this up with our label inside our SKS file. So I'm just going to jump back to SKS for a second. We have this score label, score 0, right? It's called score. That's our name of our label. All right, so we're going to refer to that. But the thing is, like as we're accustomed to in storyboards, we're accustomed to using IB outlet, then going to our connections inspector and dragging and connecting, but we're not going to do that here. We're going to refer to it by name. Our name is score in all lowercase. So that's why I'm pointing that out right now. So going back to GameScene.Swift, now what we're going to do is we're going to define our score. So we'll start off in did move. Basically at the end of did move, right after run, we're going to define our init score. So we're going to say score equals 0. We're going to say self.lbl score is equal to self.childNode. This allows us to access any nodes that are in our SKS file. So in this case, we want score. So with name / score. That's what we're using to access that label on our SKS file. And we'll say as SK label node. So we can cast it as an SK label node. Now, let's set our value. Our score is 0, so let's update our value. Or our text in the label. So we'll say self.lbl score.text is equal to score. And then we want to incorporate our score. So we'll say slash round bracket score exclamation mark. And you know what, if you want a little action to it, maybe a little fade in, fade out, we can say if let s label equals self.lbl score. We'll start off with an alpha of 0, so s label dot alpha equals 0.0. And we'll say s label dot run for sk action dot fade in with duration of 2.0. So it'll take 2 seconds. Now, just to end off, what we're going to do is we're going to do some of this code again in our hero did collide with baddie method. Right where we did a print for the word hit, we're just going to update the score as well. So moving down to that method, hero did collide with baddie. Just below, I'll leave the print up. I'll say score equals score plus score increment. And then we'll update the text. So self.lblscore.text is equal to score. So same thing again. /score, exclamation mark, round bracket, closing quote. And then maybe we'll do that little whooshing action again. So we'll say if let slabel equal self.lblscore, slabel.alpha equals 0.0, slabel.run, skaction.fade in for 2 seconds again. And I mean, because we're repeating this code again, we may as well put this into its own method in the future. And that's it. Give it a run, and you should see some scoring happening. There we go, 20, 40, 50. It's actually fading in and out so quickly that even the 2-second fade in and fade out isn't good enough. Okay, so let's see if I can, there it is, a little bit of a fade happening. But now it's happening so fast that this is just flickering at this point. We're really doing good. And so essentially, that was SpriteKit. So a little introduction to SpriteKit. But again, you can take this further any which direction you want. Adding lasers, adding projectiles, adding a whole bunch of different fun things as you see fit.